friends. This is Mr. Stirrup here about CP Algebra 1. So let's go through a couple of these problems. Why don't you get a start on these, see if you can start getting a head start on it. So you might remember we were clearing denominators. We want to get y by itself. So I have two denominators. I have a 3 and a 6. And 3 goes into 6, and 6 goes into 6. So I'm going to multiply everything by 6. And when I do that, there's nothing to reduce on the first one, so I just get 42. Plus, the plus sign comes down. 3 goes into 6 twice, and then 2 times that original 2 is going to give me 4y. And then 6 is going to cancel out. It's going to give me 1, so that's 1 times 1y, which is going to be 1y or just y. And then at the end, there's nothing to reduce, so it's minus 30. And let's go ahead and do our little dotted line straight on down. And let's get y by itself. So I would choose to maybe subtract 4y from both, or y from both sides. You might have chosen a little bit different, but your answer should come out the same as mine. And that's equal to negative 30. Subtract 42, subtract 42. So those cancel, so I get 3y is equal to, what is that, negative 72. And then divide each side by 3. And 3 goes into 72. Would have been y equals negative 24 if we had done that right. And you can do that probably on a calculator if you needed to. Just go 72 divided by 3. All right, second problem. Big thing on this one is let's make sure we distribute first. So I get 6a minus 8. Nothing happened to those yet. Plus 12a minus 9. And that's equal to negative 17. We do have some like terms. So I have 18a minus 17 equals negative 17. Let's add 17 to both sides. And notice I get 18a, because those canceled out. 18a equals 0. Well, what times 18 gives me 0? Yeah, you're right. 0. So a is equal to 0 on this one. And that's the real answer. So I know some of you every now and then you put there's no solution to it. Well, no, there is a solution. The solution happens to be 0. Okay, is there anything else on this page? Nope. All right, so we're going to be dealing with inequality. So we have less than, greater than. So we have this little 2 alligators or crocodiles or crocodigators if you speak stirrup language. So less than is going to the left, greater than is going to the right. And let's build upon that a little bit. So inequalities, so less than, greater than. This is less than or equal to, so we include it. And this is greater than or equal to. Okay, so let's keep that in mind as we progress on. All right, so we want to graph these following inequalities. So we're going to use a number line to take a look at this. So I'm going to draw myself a little number line. And I'm going to put 4 or 0 right here, and I'll put 4 right here. But I just want greater than values. So I'm going to have an open dot because I don't have an equal there. And I want values greater than that. So that'd be like 5, 6, 7, 8. So I'm going to shade it that way. Next problem, maybe put the 0 here. And we have a negative 2 down here. Do we include the point with the equal sign? Yes, we do. So it's going to be a solid dot. And I want values that are less than or equal to. So it's going to go ahead and shade that way. And we have a solid dot on that one. So we'll be looking at that as that for teachers. Next problem, I want values less than 0. Well, we have 0 here. Do I include 0? Is there an equal sign? Nope. So it's going to be an open dot. I want values less than 0. So we're talking about the negative numbers in this case. So that's going to go left. And then last problem. If I have negative 10 down here, I guess I got to have 0 here if I wanted to have show which direction. Do I include the negative 10? There is an equal sign, so I include it. So it's going to be a solid dot. And we're going to shade it to the right. Yes, I got a little music playing for our entertainment purposes. Now, we got a couple of these down here that look a little bit different. We got a little, this is called a compound inequality. So I know I have negative 2 and I have 4, you know, and like 0 would probably be somewhere in there. So I'm going to have an open dot at each of those. So negative 2 is less than x, which is less than 4. So I'm going to shade the region in between these. And so I have these two open dots on there. And that's what that's going to look like. And then our last question on that page, same idea. I have 0 here, I have 10 here. Notice I have one solid dot because I have an equal sign at the 0, but I have an open dot at the 10. So I want values that are greater than 0 and less than 10. So I'm going to shade the region in between them. Notice I have an open dot and a closed dot. That means I include one of the endpoints, but not the other. So now we're going to talk about interval notation. And interval notation is a way that in math we can identify where we're talking about. So on a number line, just quickly, this would be 0, 4 with an open dot going this way. We read interval notation left to right. So I start at, and I'm going to use a rounded bracket. It's called a soft bracket a lot of times. So I'm going to go from 4, but this is going to infinity. So I'm going to go from 4 to infinity. This is interval notation. That's not a point. It's interval notation. This next particular problem, I have -2. Say I have 0 here. So I'm going to include -2, so a solid dot, but I want values less than it. So that's going to negative infinity. And again, I read this from left to right. So my interval notation will be from negative infinity to -2 with a square bracket. It's a square bracket on the -2 because I have the equal sign. It's a soft bracket on the negative infinity because I can't get there. Okay, we approach it, but we don't ever get there completely. Okay, on this one, a lot of times we can look at a number line saying, hey, I got an open dot and I want values that are less than. So again, that's going to negative infinity, and read it from left to right. Well, we're going to go from negative infinity to 0. Is it a soft bracket, round bracket, or a hard bracket, square bracket? Yeah, it'd be rounded because I don't have an equal sign. Okay, so this one, I got -10 down here, I got 0. I have a solid dot, and we're going to shade it this way. Okay, so notice I shaded above the line here. So read it from left to right. Square bracket, -10, hard bracket to infinity. And then we get one that's the compound inequality. So again, we have -2 here, we have 4 here. We have open dots at both, and we're going to shade in between the two. They're both soft brackets, so I'm going to get -2, 4. So I have two soft brackets. This is not the point -2, 4. This is interval notation saying we go from -2 to 4. We do not include our endpoints. And then this one we go from 0 to 10. We have a solid dot here. We have an open dot here. So what do you think of your bracket? Is it going to be soft and hard, or hard and soft? Yeah, we have a hard bracket at 0. We include 0. We read it from left to right. To 10, rounded bracket because we don't include the 10. All right, so we want to write, we've already done this. So open dot, so I have an open dot at -2, and we're going to infinity. Rounded bracket at both because I can't get to infinity. Number 2, it's going to be a hard bracket, so square bracket to infinity. Again, I'm reading it left to right. Remember, this one is coming from negative infinity. And we're going to 0, and that's a rounded bracket at the 0, soft bracket. Again, if you have questions on these, make sure you ask about it in class. Let's see. Define the variable, write it as an inequality in an interval notation. Model each as the following situation. Also decide if it's discrete or continuous. Okay, discrete means I would go point to point to point. Continuous would mean it would be, I would have values in between. So it says the temperature of a cooked chicken needs to be above 165 degrees. To be above. Okay, so it's going to be 165 up to infinity. Really, we wouldn't cook chicken up to an infinite temperature. It's a rounded bracket because we need to be above 165. And then this would be continuous because I could have 165.2, 165.3. So continuous would be what we do there. We have the decimal amounts in between. Your bank account cannot go below a $50 balance. Cannot go below a $50 balance. So we could be at 50, but then we could have an infinite amount of money. Boy, wouldn't that be nice? An infinite amount of money, buy anything we want. Have some cars I'd keep my eye on. So this would be discrete And the reason it would be discrete is if we were to even go down to the nearest penny, like if we had $50.12, but then I could have 13 cents or 14 cents. I can't have like a lower decimal than that. But double check with your teacher if they want this one to be discrete or continuous. I'm thinking it has to be discrete because we have a cut-off decimal, but they would be able to answer that for you. To make the varsity team, you have to run the 100-meter dash in under 11 seconds. So you're not going to run negative time, right? So you're going to do more than 0 seconds and less than 11 seconds. And they're both rounded brackets. So obviously you can't run the 100-meter dash in 0 seconds. And I would say this would have to be continuous because our stopwatch might have some far out placeholders. So it keeps going. And the number of people in an elevator cannot exceed 12. Well, we could have 0 people in an elevator. We've all had an elevator open, there's nobody in. And we cannot exceed 12. And that's also going to be a square bracket. And that's going to be discrete because we're going to have people. So we can't have part of a person in there. So that'll be discrete. And that's it. Make sure you take a look at your homework. Bring in any questions you might have to class. Take care of one another, my friends.